Hello students, in these slides I am going to discuss about dispersion by a prism. Dispersion by prism. See, the white light is split into 7 constituent colors when it is passes through a suitable medium is known as dispersion. And dispersion by prism means we need to consider one prism like this. This is a prism. When a white beam, this is a white light beam which incidents on the one of the refracting surface of the prism. So it's split into 7 colors and we can receive on the screen different colors pattern that is called as spectrum. Spectrum, the band of colors obtained when a beam of composite light undergoes a dispersion is called as spectrum. See, you can see here in the prism case when the white light or a white beam is incidenting, so it is split into 7 colors. From where we are getting the 7 colors? See, white beam or a white light beam in which all the colors are there but they are moving parallel. Angle between them is 0. The combination color is appearing as white. If we create the angle between all those colors, we can see them distinctly, separately. So prism work is to create the angle between the colors and make them to move in different directions, which give the sense of 7 colors patterns. We are calling that as a spectrum. Dispersion takes place because of refractive index of a medium for a different wavelength. Color is different. We know that in a electromagnetic spectrum in the visible region, which is including red to violet, so red is having a maximum wavelength, violet is having a minimum wavelength. So refractive index is inversely proportional to wavelength, means for the red color refractive index of the medium is less, therefore bending capacity for the red color is less. For the same medium, for the violet color, refractive index is more because its wavelength is less. Therefore, bending capacity is more for the same medium. Therefore, wavelength is a matter which gives the dispersion here. Example, for a red color, refractive index is less. Deviation D is less for red color. When a white light passes through two similar prisms placed inverted to each other, the beam from the first prism will fall on the second prism. The resulting beam will be white light. That means by the combination of the two prisms like this, when the white beam is incidenting on the left prism, so it will take a dispersion. 7 colors are splitted up like this. And if those 7 colors after coming from the other prism, they are entering and after refraction they are meeting at a point, and while coming out that comes as a white beam light again. We are getting on the screen white beam because it is a combination of colors once again. Rainbow. What is this rainbow? You might have seen the beautiful nature here. It shows a rainbow, right? So what is this rainbow? How it forms? Rainbow is the phenomena due to the combined effect of dispersion. Color splitting is because of dispersion, and we want to see that one, means there are other two cases are taking place which are nothing but a reflection and refraction. So combined effect of this dispersion, refraction and reflection of the sunlight by the spherical water droplets itself is known as a rainbow. Formation of rainbow. Sunlight is the first refracted as it enters the raindrop, right? It moving from rarer to denser medium, therefore it bent towards normal. When it enter on the second surface, the opposite surface, so if the angle of incidence is more than critical angle, it will be reflected back. So it will coming out once again. The reflection is also taking place, refraction is also taking place. When it is taking a refraction, it's split into 7 colors. So dispersion is also taking place. So red color bends the least, white color bends the most inside the droplet. Let us take this is a rain droplet. When the sunlight, which is a white beam, is incidenting, it's split into 7 colors. We are showing here only red and violet. And at the second opposite phase, when it incidents, if it is more than critical angle, it will be reflected back. These component undergoes total internal reflection inside the raindrops if the angle of incidence on the inner surface is greater than critical angle, and for the water critical angle is 48 degree. So that means if more than 48 degree, if it incidence, both are reflected back. So while coming out, they are emerging like this. The reflected light is refracted again as it comes out of the drop. So it makes an angle 40 and it makes an angle 42. For the violet it is 40 and for the red it is 42. It takes It's found that the violet light makes an angle of 40 degree and the red light makes an angle 42 degree with the line joining the sun and the observer. That means we are standing on the land, the earth, and we are seeing about how much angle we are getting here with respect to the sunlight. Okay. So with respect to that sunlight, the angle made by the violet is 40 and angle made by the red is 42. For other colors, angle lie in between these two colors. Okay. So not only red and violet we are seeing, we are getting the 7 colors which are overlapped. Okay. Primary rainbow. So how the primary rainbow is taking place? We have taken here 2 droplets. Let us take, this is the direction of the ray entering. Okay, the observer is here. Sunlight enters like this. It reflected. See, I am not showing any 7 colors, but there is a dispersion. And these rays are reflected back. All the 7 colors are reflected back and those are getting entry like this. So when we are going to see like this, topmost color is appearing as red, bottommost color is appearing as violet. So this phenomena is known as the primary rainbow. So it is appearing in the half ring shape, and here it makes an angle 42 and this makes an angle 40. In a primary rainbow, the observer sees the red light from drop 1 and violet light from the drop 2. The violet light from the drop 1 and the red light from drop 2 are directed at level above or below the observer. Thus, the observer sees a rainbow with a red color on the top and violet color at the bottom. If red appears on the top, violet appears on the bottom, then it is called as the primary rainbow. Now secondary rainbow, what happens if the violet appears at the top and red appears at the bottom? That case also it comes. How it is taking place? When a light rays undergoes 2 internal reflections in a raindrop, a secondary rainbow is formed. Instead of one reflection, 2 reflections if they are taking place inside the droplet, it gives rise to the secondary rainbow. So like this, rain droplets we have taken. This is the direction, that is the earth surface. The observer is here on the earth, the sunlight enters like this and it will be refracted and dispersed. Dispersion means there are 7 colors and it is taking place once again internal reflection from other side and it is emerging out. So when it is emerging out, see, the topmost is violet and the bottommost it appear as red. So this makes an angle 53 degree and the red makes an angle 50 degree. The intensity of it is reduced at a second reflection and hence secondary rainbow is painted. See, which rainbow is painted if the question arises. This is the question arising in the CET format, not in the theory part. Okay. So intensity of it is reduced as a second reflection and hence secondary rainbow we are calling, and it is a painter. Painter means its intensity is less compared to primary rainbow. Okay, and where it forms, comparison with primary bit below, because angles are between 40 42 you already learned, and here it is 52 53 bit above. So in angle it is bit above means when it comes above bit, so violet is appearing top and red is appearing at bottom means in the droplets 2 times of a reflection is taking place, that is internal reflection. Further, the order of the color is reversed in it, that is red at the bottom and violet at the top. Scattering of light. Now scattering of light. What is this scattering? The change in the direction of the light propagation when the light is incidence on the substances is known as scattering of a light. You can take the example here, when the light source incidence on the substance, the light is scattered in all directions. Scattered light means in all direction it spreads. Coherent scattering. What is this coherent scattering? When the wavelength of the scattered light is same as that of the incident light. If incident light wavelength and scattered wavelength both are same, means such a type of a scattering is called as coherent scattering. Example, Rayleigh scattering is related with this coherent scattering. Incoherent scattering, what is this incoherent scattering? When the wavelength of the scattered light is different from the incident light. Yes, so incident light is having a different wavelength and scattered light is having a different wavelength. Such type of a scattering is known as coherent scattering. For example, Raman effect related. Okay, Raman scattering is nothing but it is an example for incoherent scattering. Rayleigh law of scattering. The intensity of a scattering, that is amount of intensity, is inversely proportional to the fourth power of the wavelength. Wavelength means we know the color to color the wavelength changes. So scattering amount for the colors also changing. The amount of a scattering or intensity of scattering varies inversely as the fourth power of the wavelength. That is, I is taken as intensity proportional to 1 by fourth power of lambda, lambda to the power 4. The blue color of the sky. What is the reason behind this one? Simple reason is scattering of light. Because of scattering of light, the color of the sky is blue. According to Rayleigh scattering, the intensity of scattering is inversely proportional to the fourth power as it is known to the wavelength of that particular. Okay, color to color wavelength changes. Since the wavelength of a blue color is less, it is scattered the most in comparison with others. See, like this, blue color is scattering more. Why we are not taking the violet and indigo? Because human eye is sensitive for this blue color. That's why we are considering blue color. But in reality, the more scattered is taking place for the violet color. And second most is for the indigo color. Third most is for the blue color. But human eye is sensing the blue color most. That's why we are getting the blue color scattering more here. Okay. Actual scattering is for violet color. Yes. Maximum scattering is for violet color. But human eye is very much sensitive for the blue color. We are sensing it more. Therefore, we are seeing the sky as blue. Okay, since the wavelength of the blue color is less, it's scattered the most. This is the reason we are giving here. Due to this, blue color predominates and sky appears blue. At sunrises or sunset, the sun looks almost reddish. See the diagram? The same thing you can see naturally there. When it is at the sunset or sun rises, it appears as a reddish. What is the reason behind? Only reason is scattering of light. When sun is at the horizon, okay, sunrise or a sunset, the light from the sun has to travel a larger distance in the atmosphere because it is having a larger atmospheric thickness in the horizon region. So light travel more, but when it is entering from rarer to denser, scattering of the light is taking place. When the scattering of light is taking place, we know red color is having a maximum wavelength, and Rayleigh scattering tells that amount of scattering or intensity of scattering is inversely proportional to fourth power of wavelength. As the wavelength is maximum, scattering amount for the red color is minimum. So other colors are scattered and the less scattered is entering our eye and we are seeing the sun as red. Due to this, more of the blue light scattered away and sun appears reddish. See, distance of the atmosphere through which the sunlight travel. If it is at the midday, the distance traveled to the atmosphere to the earth surface is less, and horizon it will become more distance traveled. In that case, scattering amount is taking place for the other colors more scattered, and for the red color which is having a maximum wavelength having the less scattered or least scattered. Now, red light is used in a danger signal. Why? Red light is used in a danger signal so that they can be seen distinctly up to large distances. Other colors are scattered more. For the long distances, less scattering is red color. That's why the danger signals are made of this red color. The light used in a danger signal should not get scattered much. Since red color is scattered through a small amount due to its longer wavelength, the danger signal makes use of red light. Fourth one, the clouds are generally white. What is the reason? The larger particles like a dust, water drops in the atmosphere scattered light of all colors at most equally, and hence clouds are white in colors.